monthly space news, focusing mainly on the Starship and actually what the Chinese are doing, a combination of those two things. You've probably heard Elon Musk talking about going to Mars. In fact, he calls it the gateway to Mars. That may be a slight dig at the lunar gateway that NASA's doing, but fundamentally, he's just saying, we need to go to Mars, and here's a ship that'll help get us there. That is Starship, and they just completed flight test number 3. It was launched on March 14th. It basically was nominal, and in most ways nominal meaning good, meaning it worked as expected. It made it to near orbit, which was the plan, but even more basically, it didn't damage the launch pad, so now they're well past that problem that they had on test number 1. All the engines fired and completed their full duration burn, which they had before. The hot staging worked, meaning they start the second stage before they release from the first stage. That was risky for such a big rocket. They've now demonstrated that works twice. They got up to orbital speed and altitude, which is really what the goal was. And it looked like the thermal tiles held together, so they stuck to the ship much more than happened in the earlier tests. One way to look at this, still the way it gets reported in the news is spaceships blew up. But, when you get down to it, where were they even blowing up? It's typically after they did what they were supposed to do. All of this is related to recovering and reusing, in this case, both first and second stage. Right now, you could say this rocket has already demonstrated it can move a large quantity up to orbit. Everything is related to really reuse. That's something that people lose sight of. They say it's blowing up. Well, yeah, but other rockets don't even try to do what they're doing here. Here's an example along the way of the hot stage separation. I've got a bunch of slides copying the video as the launch video showed. The way you read this, like on the far lower left corner there, they're showing you which booster engines are burning. So in this case, there were just 3 in the center. Those are the ones that are gimbaled, meaning they can angle so that they can make corrections, angle the thing a little bit differently. The ones around the outside ring are just fixed. They just go straight down. And the ones in the middle, I think, are gimbaled too. The one on the right, that's the second stage. They had just started up the second stage engines, actually all 6 of them, and I think the display was probably in the process of just changing over. Because normally when the engines are off, they just show those little hollow circles like you see on the far left side. So here you're looking down from the second stage, and you're seeing the firing going on. You're seeing the control fins there, which are associated with the second stage. And then down below it, there's the first stage, which still has some engines going. So that's what you're looking at. They got some new milestones that went past the previous test. First of all, they managed to do the complete flip. The ship goes up, the stages separate. That first stage has to flip over and head back, and it tries to head back toward where it was launched from. And it blew up last time. So they now have gotten past that. And they did the full burn, meaning they slowed down as much as they needed to go into a coast phase, and then they were coasting down. And actually, they coasted back within about 6 kilometers of the ocean, but they did lose control. It was kind of a rolling oscillation. We call it roll if you're thinking of how planes or ships are rotated. It rotates left to right, indicating a control problem. Here we have a model that somebody is going to win. So it was going like this. Anybody who's ever worked in controls indicates, okay, you got a problem here. Now, it might be that it's badly tuned, the control. More likely, something probably wasn't working quite the way it should, or the model that they used to build it wasn't working quite the way it should. And these are all things that are, kind of new to Starship. So it's not the kind of thing they can test out so easily. This is how they find out if their models aren't good enough, fundamentally. You can't get good control if you can't really get a good model. What happened, though, they were losing control, and also they probably had an engine failure on restart. Maybe by now they've sorted that out. The last time I looked, they hadn't really definitively said that, but it sure looked like it. Anyway, finally it blew up. Actually, at only 460 meters, pretty close to the ocean where it was supposed to fall. So that was the booster. But in any case, they'd made it a lot further than they had before. Long term, the goal is for it to come back and land either on a platform in the ocean or actually back at the original launch site. And they're getting closer. The first step, they were just hoping to land it vertically and drop down into the ocean. They didn't quite get that. One thing that happened on both the first and the second stages was they did have these rolling kind of problems. The thermal tiles are supposed to take care of the heat. You're getting a lot more heat on the lower side. And the problem is when it rotates, the upper side is exposed. It's something they have to worry about. Now we're going to look at the upper stage. Normally the thing goes up, so it completed its engine burn to get as high as it was going to go. And then it's just supposed to coast along for a while, heading along where there's essentially no atmosphere to speak of. That's further than they ever got before, because the last time it blew up at that point. There were 3 tests they wanted to do. One was transferring fuel, and they were just doing it between a couple of tanks. There's a little tank way in the very front of the ship, and there's a big one in the middle. And they were just transferring fuel. They need to show they can do that in zero gravity conditions because they need that to go to Mars. Even to go to the moon, fundamentally, you need to get a bunch of fuel up there at a fuel depot, which will just be another one of these, and transfer fuel to it multiple times to basically gas up so they can then go to wherever they're going, the moon or in the future to Mars. So they were testing that out. The result was they said it worked, but of course we can't really tell, and they didn't really have final results on that. They were also going to test the payload door opening, specifically for the style of launching satellites that they want to do for their own Starlink. I've got a slide on that later. And also just testing out the control. I've got a slide on that later, too. They also, at this point, established the first hypersonic reentry. Now, once you've gotten up there, and as you start to come down, you're going at orbital velocity, which is at that altitude is like 17,000 miles an hour, 25 times the speed of sound. That's hypersonic reentry. They hadn't actually done that before. So this is the first, and that's why they have those tiles. Now, as I said, it turned out they had a rolling problem, and so the thing was upside down even at times, and as a result, that definitely hurt it. So they found out that they need to improve their controls. But basically, they're testing the heating. Are the tiles good enough? They're testing the control systems and just the aerodynamics in general to make sure they understand how the vehicle is actually going to work. Because you really can't test it that well on a ship this big. You can't just throw in the wind tunnel. You don't have a wind tunnel that big, especially a supersonic one. And just to point out on this display, like the lower right corner here, you see, indeed, the engines are off. That's what it looks like when they're just coasting. And they show the orientation. If you're looking along the bottom there, there's a little place they're showing the thing is slightly angled up, is pitched slightly up, which is how it was supposed to be at that point. I just want to show these things because these things change as we look. Now, one thing you'll notice in this picture, they're showing that the Earth looks kind of vertical to it here. That's because the thing is rotating. And every one of these, if you looked over time, every time you looked at it, the Earth was in a different position. And because it was rolling, they lost control, which ultimately would lead to its demise. As far as the in-orbit fuel transfer test, this shows a diagram of an earlier version of Starship. Every one of these ships has what are called header tanks. It's a small tank. They keep those so that they can guarantee that there's no vapor anywhere. They keep them under high pressure in the front end so that when they want to restart an engine, for instance, even in zero gravity, they don't have to worry about it just having a bunch of gas and liquid kind of floating around aimlessly and the engine's not working properly. So that's called a header tank. And that's a typical kind of thing they have. The test they were doing was just moving some stuff from the header tank over to the main tank, which is there kind of in the middle of the thing. They moved about 10 tons of liquid oxygen, or at least that was the plan. The results haven't really been published yet. NASA is quite concerned because NASA needs this to work. So in the future, in general, this is sort of the conjugating paramecium kind of a picture. I don't know how thick those pipes are supposed to be, but somewhere in there, there'd be pipes so that you're going to be passing fuel from one ship that came up laden with fuel, fueling up the other one. So that's what they expect to be doing in the future. And as I said, that is important to NASA, specifically Artemis 3, which is the very next moon launch. That's the one that will actually take a crew to land. If you're going to do that, though, it takes multiple loads of fuel for one of these starships going up, multiple loads of that as the payload to go up. So what they do is they start off with an initial launch, which should be the one on the left over here. It goes up, and then several launches are done to go up and fill, and then they return. So that whole cycle is not quite shown on here, but there'd be multiple launches and returns to Earth. At some point, then, they launch the SLS that actually is carrying the human crew. They take it up, and they meet up in orbit, and they transfer the crew to the human landing system, which is a Starship, one of these, except it doesn't have fins because they don't do any good around the moon. They're never gonna see an atmosphere, so they don't have fins and a few other things associated with atmosphere. They would then go and they'll land, and then when they're done with their mission, then they'll take back off, and they come back, and the crew returns to Earth. So that's the whole thing. But all of this depends on refueling in orbit. So this matters to NASA. It matters to SpaceX and for all future missions, including Mars. So I mentioned the testing of the payload doors. They're calling it a Pez dispenser for people who are younger. That was a kind of a candy. I don't know if they still even have them, but they were sort of like chalk. They were in a tube like this, and you could shoot out a little pellet, one at a time, kind of a chalky kind of a candy. That's what they're doing is they're going to send out the satellites kind of in little flat packs, one at a time, shooting out the door. And the door, you can see it here at launch. It was closed. It's this little thing right in the center of the picture. That's the initial outside view. This was right during the takeoff, 4 seconds into the launch. All the boosters, engines firing. This is what it looked like inside. And so what they did is, once they were up, the second stage is just floating in space, then they had pistons, which are shown here, which open a door. Now, it's a little hard to tell if you look at the picture by itself, but look at the bottom center of this picture. There's some little traces of gas there. They're just kind of open to space at that point. There's still some moisture or whatever kind of wafting its way out. And if you look at the next one, it looks kind of bluish, but that's the door closing. So they started off with it completely closed. They didn't show that, but then they showed the door open. Some of the earlier parts of the launch, you can see more and more of that vapor there. And then if you watch again, that door was closing. Now, it wasn't actually clear that the door ever got fully open or the door got fully closed. You couldn't really tell that. I mean, I'm sure they know, but we couldn't really tell by looking at it. So some people have raised questions about that. But anyway, at least they've started now. They've done some testing, at least on opening and closing the doors, which will be a necessary part of deploying satellites.
In the live video, that door looked off as they were moving it around. It kind of was all over the place.
Yeah, it wasn't completely convincing, but at least it's a start. Note again that the craft pitch here is essentially zero. It's just going along, kind of coasting. Now, the next one, you'll notice here it's pointing up. They've lost control at that point. It should not be pointing up. The pitch is wrong. So there's two problems. The pitch, meaning it's now pointing up instead of going sideways like it was supposed to be doing. And the other thing is it's been rolling. So there's at least two axes of rotation that are screwed up. So that, they've lost control. But it doesn't hurt it right away. Now, as I said, it's pointing up. You'll notice also, if you look down, those white things in the bottom, those are the clouds. So you're looking down directly at the surface of the Earth, which you weren't in some of the earlier pictures. Remember looking back, one of the earlier second stage. Clearly, there's a lot of rotation going on here that is not really desired. So they have to work on that. Now, the other interesting thing is that when you're going that fast, you get plasma. What happens is you're hitting the few particles of air that are there, you're hitting them so hard, they essentially dissociate into ions. It's called plasma. That looks like it might be some kind of engine. Now, all that red kind of look there, that's not. That's just plasma. And that was interesting because that was also something new. Normally, when you got a rocket coming down, you're trying to communicate with the ground. Well, all that plasma is forming in the front, the front and immediate sides of the vehicle. You can't transmit a signal to show a picture of that. But here, they're transmitting to satellites that are above it, so they could. So they actually were able to show this. That was something new. Nobody had actually seen the plasma that gets generated. No one had ever seen that during that descent phase. This was actually during the descent. And here's yet just another scene here. Again, that sure looks like it might be rocket engines. Nope, that's just plasma. And that was one of the more dramatic ones that were there. So they did have problems. It all comes down to control. They couldn't control the attitude, meaning the orientation, pitch horizontally, vertically, or the rolling. And of course, once again, the thermal tiles then are not doing their job because they're not in the right place all the time. So they had a problem. They did skip one test, which was an engine restart. You want to make sure that you can start your engine in space. They hadn't actually done that yet. But because they'd already lost control, they didn't want to make things worse. So they didn't do that. And then the ship, finally was just lost during reentry. And in terms of orientation here, this is a case where here the ship was pointing down. It's just clearly lost control. Okay, next topic, the Chinese Lunar Exploration Program. You were asking about this symbol. The symbol is meant to vaguely suggest the Chinese character for moon, which is, in fact, among those four characters below it, that's actually that one right there. That means moon. But the other part of this is symbolic, is those are supposed to be human footprints, indicating human footprints on the moon. Now, of course, they can't really be real footprints. Your feet would be destroyed instantly from the cold. So maybe that's why they're so fat. They're in boots. Which reminds you of the old Space Force show where they were talking about landing on the moon, and the general says, we want to see American boots on the ground with American feet in them. Well, they want to see Chinese feet in them. The first two characters are China. It's middle. The first character is middle, and the second one is country. They always thought of themselves as the center of the world, and that's kept up ever since then. Okay, so early launches. Going back to 2007, they've been doing this for a while. Now, so far, they've all been robotic. Of course, that's going to change in the future. They have a whole program series named after the moon goddess, Chang'e, and they've been improving the capabilities over time, and also doing a lot of other exploration. After they dropped off an orbiter around the moon, while they're at it, they had some extra fuel. They decided to go over to the Earth and the Sun, L2. They just moved around, they went and they did an asteroid flyby, and then they just went on to deep space. So they're getting good use out of these craft. They finally did land. 2013, they had a lander and a rover, and that was on the near side of the moon, being the part that you can always see, the northern hemisphere. And then they had a test really for future landings where they wanted to make sure that they could actually return samples to Earth. So they didn't actually go down on land and take a sample, but they did everything else. They sent the capsule back. They made sure that they could get it back to Earth and recover it. So they tested all that out. And then they put up a communications relay. They needed that because they wanted to land on the far side of the moon. So if you're on the far side, you can't have a radio signal going directly back to Earth. So they thought about that. They figured out what to do about it. And here's what they came up with. Actually, the idea of a halo orbit, there's actually a lot of early American literature about that. It's not a new idea. They were actually the first to do one, though. That was one thing that's different. Let's start on the right-hand side of this diagram here. So you got the Earth where the monitoring stations are. You got the moon, which is rotating around the Earth. The moon is going in a circle around that, flat on that screen. So the near side always points to the Earth. The far side never points to the Earth because the moon rotates just exactly at the right speed to make that happen. Now, there's a point called the Lagrange L2 point, which is out here on the far right-hand side, where you can have an object like a satellite moving at the same speed as Earth, the rotational speed. So it kind of looks like the left-hand side here, where say you got the Earth in the center, you got the moon in that circular orbit. You draw a line between the Earth and the moon here, and there's Lagrange point 1 and 2. 1 is where there's exact gravitational balance between Earth and the moon. And it's easy to see that one because you can imagine if you just got a little closer to the Earth gravity would start to win out and it would pull it away, or vice versa going to the moon. But you have a similar kind of thing going on where normally you expect if you're farther away from Earth, you'd expect the orbital speed to be slower in angular velocity in particular, but it's not. And the reason is you have the extra pull of the Earth, and that's maximized right along the line between the Earth and the moon. So that's why it's pulling it along. So that L2 point, that's quite strategic because you can't transmit anything there. The moon is always in the way. However, if you have one going in a circle around it, or back to the picture on the right-hand side here, they put the satellite in an orbit around the L2 point. Now this is an orbit perpendicular to that screen. So you're far enough out, as long as you're up high enough, you always have a view of the Earth. And that's what's shown in these green lines here. You know, no matter where you are, that satellite can always communicate with Earth. And that's why you put it out that far. Now you can't necessarily communicate with everybody on the far side because at some point the curvature of the moon gets in the way. But you know, you can cover most of the moon anyway. So that's what they did. And actually, the Lunar Gateway is going to be in one of these kinds of an orbit as well.
There was a question, is there a gravitational pull towards L2?
It doesn't really get pulled, but it takes minimal fuel to do it.
One of the attendees brought up the representation of the forces like gravity on the satellite as a bowl. The easiest orbital path is to fall down into the bowl, but that would imply that the orbits around the Lagrange point are stable, and a satellite would eventually spiral into the Lagrange point. That's not the case for L1, L2, or L3. As we discussed for the L1 point, for example, if you get slightly off of L1, you get pulled more towards Earth or the moon. There's a balance of gravity exactly at L1, but it's not stable. Think of it more like a ball balanced on the top of a very sharp mountain peak.
Yeah, it's not quite that simple, though, because that's true for the L4 and the L5 points. They're actually stable. I mean, meaning exactly as you described. If something gets off of it a little bit, it'll get pulled back in. And that's why they have all those asteroids collected that what are called the Trojan points around Jupiter.
L4 and L5 for Jupiter's orbit of the sun.
You go out there and there's just a whole pile of asteroids like kind of all accumulated there. They just collected it. And there's two of those, there's L4 and L5. It's more complicated here. You can drift off, but it still takes very little energy to. So anyway, the big advantage of that orbit is never blocked from Earth. And you can cover most of the far side of the moon with doing that. Okay, so Chang'e 4, that one actually had a lander and a rover. That was the first one that did that. And that was in the South Pole region on the far side. So they had a lander and a rover. They didn't have sample return as part of this project. But anyway, it looks like that. There's the lander on the left side. The rover rolls off. Now, as far as the landing site, this is a picture of the moon on the left-hand side. This whole area where they landed is called the South Aitken Basin. There's a bunch of individual craters inside that, shown in more detail on the right-hand side. But the point is, you're not actually at the poles. But everybody's kind of interested in the poles just because there's a whole variety of reasons for that, like availability of water. So everybody's focusing on that. And even back then, they were trying to get relatively close. So Chang'e 5, now it is an orbiter and a lander. And this is the ascent vehicle, so it looks a little bit different because they took samples. They didn't have a rover in this case. They just took samples directly. I think it could go down like 6 feet or something. Drilled a bunch of samples fairly quickly and then returned. And so this is fairly elaborate operation. You got to go up, you meet back up with the orbiter. The orbiter then heads back to Earth, and then it drops off a sample capsule. It's pretty much actually a lot like the Apollo missions went. It was a similar kind of an architecture. But anyway, them doing that. The point is, it's a fairly elaborate kind of thing. They did it. They managed to take samples back from the moon. I would add, by the way, the United States never did that. We did it with people, but we didn't, which is, a whole lot harder in some ways because of all the life support issues. But actually, to do it in an automated fashion like that, that's actually pretty impressive. The satellite, then, they were using before, I talked about being in a halo orbit. Well, they rethought that after their experience. The problem is it still takes fuel to maintain that orbit. So the new one, which is Chuichao 2, is bigger, it's more powerful, but they have the same issue. They want to get communications with the far side of the moon. They just have a bigger one. The antenna is the same size, but everything is more powerful otherwise. Everything's bigger. And they also sent up a couple of smaller test satellites. Long term, what they want to do is they want to have a network of communication satellites so they can communicate with their rovers and their landers and everything on the near and the far side of the moon. So they're setting all that up. So its orbit is different, though. They just went for a very highly elliptical orbit. And this is not to scale. If that were to scale, it wouldn't fit on the screen because it's like a 200 by 16,000 kilometer orbit, like a 1 to 800, meaning if you were 1 foot wide, it'd be 800 feet long, and it doesn't fit. So they had to take some liberties in this picture. It ends up with a 24-hour period. I think it starts off with 12. But anyway, the point of an elliptical orbit is that basically you spend most of your time, you're going very, very slowly when you're farthest from the moon as it goes around. When you come in, you start going really fast. And you can kind of think of that as a trade-off in kinetic versus potential energy if you've had some physics. That basically, you go up high, you don't have as much kinetic energy. So that's desirable because
you may be far away, but you can spend most of your time over a target area.
There's no atmosphere in the way, so the distance isn't so much of a problem. The main thing is just being able to loiter there. So you're going kind of slowly. So that's what they're going to do. And the reason they like that is not only is it elliptical, this is what's called a frozen orbit, and that matters especially in the moon. Frozen means it's stable. And on Earth, it's not so much of a problem, but on the moon, it's a big problem. You have big variations in the density from place to place. They call them mass cons or mass concentrations. And they found actually the low lunar orbits, they're almost always going to end up crashing. They get disturbed so much just from going over these really concentrated masses. But they found a few that are they're frozen that will last essentially, maybe not forever, but for a really, really long time. But basically that any perturbations kind of cancel out. You get pulled one way, well, then you get pulled the other way, some other part of the moon. There are 4 known circular lunar frozen orbits. They found that out back in about 2006, and just partially by experiments and then I guess partially by math as they got a better feel for the topography and the gravity. They've been having orbiters around the moon for a long time, and they've been measuring a lot of this stuff, like what is the local gravity? It's not really fixed. You think about that. Earth is less of a problem because you have tectonic plate, and you got biology and wind, water, everything kind of tends to relocate the mass quite a bit. And you don't have any of that going on the moon, and that's why you have much worse problems navigating there. So anyway, there's frozen ones, but that's for circular. For elliptical orbits, somebody else did a study about the same time, figuring out where some of those would be, and they picked one of those. Where they think they're going to minimize propellant use, they hope not to do any orbit corrections for the next 10 years. Unlike the Chuichao 1, the first one, is in the halo orbit, which is kind of unstable. They need to use 80 grams of fuel for correction every 9 days. Now, 80 grams may not sound like that much, but over a period of years, they run out. So they decided to go for that. So what's coming up? Well, they're going to have a lander with an ascent vehicles and sample return. This is far side. So they're doing sampling from the far side and returning. So they're kind of putting it all together at this point. They're pretty big. It's about 7,000 pounds on the lander. 1,500 pounds of that is the ascender. The science payloads, they're not really all just from China. They have France, Italy, Sweden, and Pakistan all contributing instrumentation or various parts to this thing. All of these return about 2 kilograms of samples, 4 pounds, from the surface and from up to 2 meters below the surface. That's coming up in May. They had just launched that communications satellite. That's in place. That's working now. And now they're going to do the lander in May. What's coming up beyond that is putting more of it together. This time they're going to have a flying probe or a hopper. And not only will they be taking samples and having rovers and things, but then they'll actually jump around from place to place. They can jump down into a crater, for instance, places you couldn't really drive. So they're trying to expand what they're going to be able to do and return the samples as well. And then they're going to get a lot more serious about, okay, what do you really need to do to establish a base on the moon? They're going to do a lot more lunar science kind of stuff. They're going to do a lot more surveying to figure out what the materials are. They're going to try 3D printing of a structure, that's a real deficiency of the US programs. We're not really thinking about actually living on the moon so much. We're just thinking mainly about going there for a short period and coming back. They're making much more of an effort to figure out what do they really need to do to establish a true permanent base on the moon. And their goal is 2029, 2030, somewhere in that region, actually put people up there. So that's the start of that. Quite aggressive. They've moved that up quite a bit. It used to be, I think, like 2035, and I think they moved it up. Certain amount of competition there in the US. Now, the moon base. ILR stands for International Lunar Research Station. It is an international effort, but clearly this is definitely Chinese run. I mean, there's not any question about that. I mean, even Russia is kind of a minor partner in the whole thing. And it's mostly countries that don't like us very much when you get down to it. So there's two groups in the space race, and this is one of them, and then the American-led one is the other one. What's interesting is you have some people that are also sort of U.S. allies involved. The United Arab Emirates originally signed up for this. Remember, they had a rover in one of these earlier lunar missions that was supposed to land and go out. They were going to do that, and then people pointed out that, well, actually, the U.S. embargo won't allow them to do that. So they may actually have pulled out. It's not clear what their status is right now. They may or may not be part of it. Turkey. Actually, they've changed their name for anybody who hasn't caught up with that yet. They got tired of being confused with an American bird, so they decided to change. This is actually the name in Turkish. Turkey, yeah. But anyway, they're applying, so it must take a while to get accepted. But they also would normally be considered a U.S. ally. One minor point is just that it's likely to be nuclear powered, the overall base, at some point. Not the first mission, but at some point. Realistically, that's going to be true for anybody, just because you need a lot of power. If you're going to start using resources on the moon, you're going to start melting regolith and that kind of stuff to get metals or even just to get water out of it. You're going to need a lot of power, and it's going to probably be nuclear. It seems like the best option. Now, they have a whole variety of things labeled 1 through 5. No doubt those will all change a lot. It's probably not worth spending much time. But there is an interesting point, though, and that's if you look at it, they're emphasizing, okay, lunar in situ research utilization technology. They're focusing on the stuff they really need to go there and stay there. So I think they're taking a much more, I would say, realistic approach toward actually being on the moon. And I'll contrast that. Now, I'm going to fall into opinion here. Not everybody would agree with this. Anything on this slide you can say isn't necessarily purely factual. What I say is there's kind of two space races going on. There's one for political and economic power, and there's one for prestige. And I say the Chinese are playing both of them pretty well. We're kind of focusing on the prestige, which is kind of the old-fashioned Apollo model, where we're going to show that we're the best by putting people on the moon, and we ultimately won that one. China's, they do both, but they're kind of focusing on finding and exploiting resources, looking at what it's going to take to do the human habitation, and what they call strategic needs. And all this involves things like building materials, agriculture. They're focusing on doing a lot of this stuff. And then at some point, if fusion energy becomes a thing, helium-3 is going to be heavily involved in that. That'll all be worth a very, very lot of money. A lot of Chinese have been interested in that. It remains to be seen whether that's actually going to pay off. But anyway, it's been a big thing. On the strategic needs thing, you can read publications like the South China Morning Post. They interview these people in the space program, and they're pretty blatant about it. They just say the moon, or even the points along the way, like the L1 point between the two, which is strategic, that's just like the South China Sea. They want to occupy it, first, to make sure that nobody else can keep them out of it. Second, so they can actually tell people that they don't want anybody else coming into it. They pretty much said that pretty blatantly. They're not really keeping that much of a secret, but we're not paying that much attention to it. But anyway, so that's an issue. Now, NASA actually does look at all these things, the in situ resource utilization, how do you mine the moon, all that kind of thing. They are funding these studies, but it's not a major NASA goal or even a national goal, really, when you get down to it. Most of the funding is going for planetary science and astronomy kind of things, the space telescopes and probes to go to Jupiter and those sort of things. And those are all good science and everything. But the rest of the funding then is going to what's called the Moon to Mars program, which includes the SLS rocket. If you sum that up, I think it's a fair summary to say that its purpose is first to do some short moon visits, and by short meaning like 5-day stays a couple of times. And that's practice for going to Mars, where they're going to go and stay for a couple of weeks and then come back. You look at all the Moon to Mars plans, that's pretty much what's there. That's come under a lot of criticism. There's a guy, Rick Tumlinson, who actually has characterized that as what we're doing are planning camping trips. And I think he's right. But that's just opinion. Not everybody would necessarily agree with it. But it's something to consider. Some in the military, the U.S. military, have worried about this. And that's why you see some rather bizarre things going on, like DARPA, the Defense Advanced Research Projects Agency. I mentioned them back in, I think, October, November. They are coming up with research to figure out everything that's needed for lunar infrastructure to really actually start building a civilization on the moon. The fact that they're doing it rather than NASA is kind of telling. I mean, it basically says the military is worried that the civilians aren't doing their job, and so they're going to help out. That shows you how bad things really are when it's necessary for the military to come up with things that really should be civilian kind of concerns. So, updates on other lunar missions. We've talked about these in the past, but there have been updates. So like the Japanese had the Slim lunar lander. That's the one that landed upside down. That's that computer-generated image there. None of these have radioisotope sources of heat to last through the lunar night. It's 14 Earth days worth of cold temperature. They can't do it unless you have some kind of a heater. Most of those Chinese ones had that, and so they could survive the night, and they've been going for a long time. Most of these newer ones don't. It turns out, actually, the U.S. doesn't have that much of these radioisotopes. It's been kind of a problem. It's hard to get it. And so most missions, they just don't bother. But they were just trying to demonstrate landing. So anyway, they managed to survive a first lunar night, barely. They managed to show some operation, but some of the stuff had started to fail. They survived the second lunar night, but even more of it failed. And so I was saying last time, it's kind of like a zombie kind of a situation where, yeah, they're there, they're kind of half dead, half alive. This time, parts of the battery cells have degraded, and some of the temperature sensors stopped working. So it's on its way downhill. It probably won't last another night. Or if it does, it'll be in even worse shape. But anyway, it's impressive that it survived at all because it wasn't designed to survive the night. Another one that's on the moon is the Intuitive Machines one. That's the Houston company. They had the probe called Odysseus. They had entered a standby mode back in the end of February, and there was some hope that maybe they would wake back up. But they had the same problem. Without having the radioisotope heater, they just really can't survive the night. They didn't survive it at all. So that's over. They were the ones that landed. They were at kind of a 30-degree angle. As the guy showed during the press conference, they landed on a piece of blue plastic. Go figure. Okay, pop quiz. Who can guess the rocket in this country? Okay, somebody besides you two. There's several telltales here, and I'll tell you what in a minute. This will really mark the end of an era. This was the last of the Delta IV heavy rockets. Now, Delta IV had a long history. Delta in general had a long history. It was originally started by McDonnell Douglas, which got bought by Boeing, which then got transferred to the joint venture called United Launch Alliance, which involved Lockheed Martin. And that was in 2006. The first flight was back in 2004. It was actually a partial failure. It made it to orbit, but it wasn't the right orbit. It wasn't far enough up. But ever since then, it's been fully successful. Its main purpose, and actually it's almost its own customers, have been basically big spy satellites going up the geosynchronous orbit. It takes a lot of power to get up those big, heavy satellites, and that's what it did. They had 16 flights total, counting this one. 14 of those were spy satellites. Two of them, one of them was the Parker Solar Probe, and there was another testing out an Orion capsule, which is ironic because the Orion capsule is meant for taking humans, but that ship is not human rated. So they just needed a ship, and so they used it. But anyway, most of it has basically been used by the National Reconnaissance Office, including its last mission last month. And that is the last of all the Delta rockets, not just the Delta Heavy. It was the 45th of the Delta IVs and the 389th with the Delta name. They've evolved over time, but the name anyway goes back to 389 launches. At the time, among operational launch vehicles, it was the third highest capacity. Now, Starship doesn't count yet as operational, so it's not in this list. Right now, among rockets that have proven they can actually get to orbit or beyond and stay, NASA's SLS rocket and the SpaceX Falcon Heavy are ahead of it, but this was the next one. They can take to low Earth orbit about 63,000 pounds, which put us slightly ahead of China's Long March 5, which is their heaviest rocket. Propellants are liquid hydrogen and oxygen. For this one, unlike the Delta IV Medium, which use solid rocket boosters, which is kind of interesting. It's very unusual to see that kind of a mix, two different kinds of boosters, but they did that. It was never human rated. Now, why is that? I'm not actually sure why. I think mainly just because they didn't need it to launch spy satellites, so the market wasn't there. But there was an interesting thing, and I think one reason some people here probably knew right away what that was is you look at the black stuff that's on the rocket there. I highlighted that with the arrows. That's because you essentially get a giant fireball when this thing takes off. Apparently, it's very, very impressive to watch one of these launches. They're hydrogen engines, and they run them very hydrogen rich to begin with. And what they do is when they first start them up, they just pass a bunch of hydrogen in, essentially to purge out any other stuff. And they don't even want oxygen there because it might react with things. So they pass in a lot of hydrogen. And the hydrogen comes out the bottom. It's, where the rockets are. The hydrogen is very light, so it comes up right along the side of the rocket. So then when they finally light it up, it just explodes in this huge fireball. And they design it so that it can handle that. The paint gets charred, but it's not enough to do any real damage. So that was all actually part of the plan. So no more of these really satisfying and exciting fireballs will be available. Yeah, they're impressive. Yeah, everybody loved this rocket just for that reason, because the takeoffs were so impressive. It's been replaced by the Vulcan Centaur. That was really designed to replace that and the Atlas, which was also run by United Launch Alliance. The launch pad may actually end up getting used for Starship launches. Apparently, that's not determined yet. Okay, can you guess this country and rocket? This one might not be so easy. Okay, this is Russian, the Angara 5. They've been testing this rocket for 10 years now. This is the fourth test, and this one succeeded. The others have failed. They've had their problems with budgets and everything else, so they haven't managed to do it. It's a heavy lift vehicle, meaning it can take about 54,000 pounds to low Earth orbit, essentially competing with the Vulcan. They managed to get the cost way down. Their previous rockets were a lot more expensive. Apparently, it's about $100 million for one flight. Now, this, like other new ones I've talked about recently, is only expendable. It's a disposable rocket. So again, it's also competing with the Falcon 9 of the 2010 era, rather than the Falcon 9 of 2015 when they started reusing their boosters, which allowed them to get their costs down quite a bit. So there's not much of a commercial future for them, but they definitely want to stay in the rocket business. So this is their new one.
The propellants are kerosene with liquid oxygen.
And that's true for stage 1 and stage 2. So in that sense, they're a lot like a Falcon 9. It just took another 10 years to actually get it working. After the last failure, actually the boosters and everything were working fine. It was the second stage that was in trouble. So they have a brand new stage called Orion for the upper stage. They also have a new cosmodrome, a new launch site. They previously were launching from Kazakhstan.
The Angara rocket replaces the Proton rocket, which was launched from the Baikonur Cosmodrome in Kazakhstan. But Kazakhstan charges rental fees, and also they have objected to the use of the toxic hydrazine fuel needed for Proton. And they also expressed concern about damage from launches from their populated areas. The newer site, the Vostochny Cosmodrome, is in the less populated Far East region of Russia. It's not actually new, but it was built more recently to reduce the dependence on Kazakhstan.
Okay, one thing we have been doing every meeting is say, how many launches have we had since our last meeting, which was March 9th, so it's about a month. And that does not include the Starship Flight Test 3, because it didn't really go into full orbit. It reached that area, but it wasn't really trying to go all the way around the Earth, so that one doesn't count. So, any guesses?
17.
Okay, you're way low.
36.
No, you're high. Okay, so it's in between those two. All right, enough of that. The right answer is 28. So I'll mention a few things about a few of them here. A lot of them, of course, are just Starlink launches. They're going up all the time. They have over 5,000 satellites up there. There's a new rocket called Kairos, which I'd never even heard of. That's out of Japan. This was their first flight. It failed. They're emphasizing the quick response thing. That's been a big thing with the U.S. military lately, is to make sure that, if satellites get shot down in some kind of a conflict, you can quickly get something back up there. And they were doing the same kind of a thing. Japan was concerned about that, too. The next one is a Chinese one, the Long March 2C. They were launching some lunar satellites, apparently, into what's called a distant retrograde orbit. There were communications and navigations. This was not part of their published plan, the Lunar Exploration Program. And they really have been kind of mum. They admitted that whatever it was didn't go right. It was a partial failure because they got a launch, but they didn't go anywhere near the moon. They're stuck in low Earth orbit somewhere. But nobody really knows much about what this was, and it wasn't really part of their official plan. So we just don't know. One of the Starlink launches, the one on March 18th, kind of in the middle of the picture here, normally you typically see either 22 or 23 satellites going up for the Starlink launches. But this one included a couple Starshield launches. It's the same thing, except that there's their military satellites. And maybe they have some additional capabilities. There have only been a few of these before, so they are definitely getting involved in military applications now. I mentioned the Kuei-Chao communications satellite. That was one that just went up. Of course, there was some crew going to the International Space Station. That's still going on. That was launched out of Russia with an American and a person from Belarus and a person from Russia. Despite everything else going on, we're still managing to kind of keep the peace up there. The April 6th launch of Starlink, this one is only 21 of the normal satellites, but 6 of those, they're a little bigger, and the reason is they have the direct-to-cell capability. We talked about that in one of the earlier meetings, where they're competing with a couple of other companies, but they're really trying to set up having communications satellites. They have huge antennas to make up for the fact that they're way up in the atmosphere, but direct-to-your-cell. The original plan on all of these is to start off just with text messaging, but then over time, they're hoping actually so you can even talk. The market for these is basically not so much competing with the terrestrial-based stuff because it is more expensive, but for filling in gaps. You've got regions like national parks, or even in the US, there's plenty of places that don't actually have cell coverage. And this is going to allow that. And so they actually work with the phone companies on these. But these are the first 6 satellites beyond the initial test ones. They put up a couple test ones earlier. They're getting more serious. They got recent permission in the last month or two to expand the locations for the tests. Actually, I think Houston is one of the spots. The April 7th Falcon 9 launch, that also introduced something new. Falcon 9 has actually kind of squashed an awful lot of other competitors, in particular in the market for small launches, like the Electron from Rocket Labs and those kind of things. They're surviving, but they're not getting a huge business because what they do is they just package up a whole lot of small satellites into one big launch, and then they spread them out, and there's little space tugs that take them around to different orbits and so on. But those were all to sun-synchronous orbits. That is, they're almost polar. They're going around in polar orbit, going over the north and south poles. For people who want different inclinations, meaning like 45 degrees compared to the equator, they're now offering that as a rideshare too. They're called the old one transporter missions, and these are called bandwagon. They just made up names. But anyway, that was the first of that launch. And of course, they mentioned the last Delta flight, the Russian flight. The last Starlink flight is also interesting in one thing, and that's that for the first time, they reused a booster 20 times. So that's pretty impressive. They've got quite a few that were in the teens now. But it's amazing. They're sending up so many launches. They're probably going to do 150 or so. And they only need a couple of boosters to do this. They really are turning into the airplane model where you don't have to throw away the airplane after every trip. And that's why they can keep their costs so low. They've changed the whole model. They've changed everything. You figure Falcon 9 has reduced costs from the era of the space shuttle by a factor of at least 10. It may be even 20, depending on the time period you pick. I mean, that's huge. And for instance, you think about the semiconductor revolution. Well, every couple of years, you doubled your power, you cut the size. We're not on a curve that's dramatic as that, but a factor of 10, that enables a whole lot more applications. And Starship is another factor of 10 at least. I mean, maybe it'll be 100, who knows. But you can probably count on at least 10. It's not just economies of scale. It's the fact that you're reusing the second stage as well as the first stage and having a lot of reuse. If you launch once a year, it wouldn't make any difference. But if you're going to launch hundreds of times a year, it makes a huge difference. And so they're making it possible for us to get to space. Necessary condition, you got to have cheap access to space if we're going to ever get there in a meaningful way. It isn't enough. You also need life support. You need agriculture on the moon. How do you mine on the moon so you can use some of the dirt to build your bricks or build factories or whatever you're going to do? All that can follow, but none of that is even worth thinking about until you have a launch capability. And that's what they've accomplished on the Falcon 9 and now coming up Starship. Any other comments or questions? Yeah.
Yeah, one thing that Elon Musk has done is move the goalposts. It's not just reusability, which everyone laughed at. Oh, you're going to reuse a rocket? Like, that's impossible. And then it's like, you're going to reuse it 10 times? Well, that's just, that's not going to work. And now 20 times, it's just like every 2 years or so, he's moving the goalposts for everyone else.
Yeah. Well, and then reusing the second stage, which is also, of course, everybody said, well, that'll be impossible because it's already up there so high. It takes a lot more fuel to get it to come back down to Earth. Well, they're working on it.
Very reasonable people in business who carefully explained in monographs and reports why it was impossible.
Yeah.
Why it was possible, but economically not worthwhile.
Yeah.
And now it's like,
Well, and part of that's from having better control over the vehicle. So, for instance, both the first and the second stages in Starship, I mean, other than the initial turns, they're not relying on the engines firing to slow them down that much. They're just relying on the atmosphere slowing them down. And even starting from way high, they have to get down somewhat. But once you get anywhere close to an atmosphere, they're letting the heating tiles take over. And they're doing a much better job of that than anyone did before. So they literally just kind of coast down until it's almost time to turn the rocket engines back on, flip over and then land. And that's very different, even from, say, moon landings, which typically you turn on your engines and you keep them on the entire time, all the way from being in lunar orbit all the way down to the ground.
Discussion continued on reusability. Doug felt that existing vendors may adopt it, but not push it hard enough. For instance, the Boeing Starliner capsule carrying crew to the International Space Station might be reused up to 10 times, but with a 6-month turnaround. The Orion capsule used in the Artemis moon program only has parts that are reusable, and also will take a long time to refurbish. With Starship, they're working very hard to make sure that refurbishment will be fast and inexpensive.
So how long does it take to turn it around? The space shuttle was reusable too, but it cost
A lot to refurbish and took a long time. It wasn't cost effective.
whereas all this stuff has been designed to be just much, much simpler and to hold up. That's why they're using stainless steel. It can take a lot more heat. It doesn't matter if it gets so hot, it doesn't melt.
There was also a lengthy discussion on what it would be like to work for SpaceX.
It's kind of the Silicon Valley approach. It's pretty much high pressure, long hours, you give it your all. Maybe you burn out, maybe you don't. But it looks good on your resume, even if you burn out. Everybody knows that, okay, at least you participated in that, and that's worth something.
And the word's got around. It's like, you worked for, that company for a while, for like any length of time, and you could stand up to that, you could stand up to anything.
Yeah.
And it was like working for NASA in the 1960s.
Okay, that ends my talk.
Other space-related videos or slide presentations by me are available at the link shown here. That includes a list of videos at my YouTube channel, so you can view them or subscribe for notifications about future videos. These presentations are mostly made as part of the meetings of National Space Society's North Houston chapter, and the link to that is shown. Topics like these are presented as part of a monthly news segment, and there are also lots of other interesting speakers and open discussions. You can attend in person or online via Zoom. Come join us.